Have you ever wondered how apps like WhatsApp, Instagram, or Facebook work on both Android and iPhone without developers writing two completely different applications? What if I told you that you can build one application using a single code base and run it on multiple platforms? Sounds amazing, right? In today's lesson, we are going to learn cross-platform development from the ground up. We'll understand what it is, why companies prefer it, its advantages and disadvantages, the most popular frameworks like Flutter and React Native, and when you should choose cross-platform development over native development. Whether you are preparing for university exams, interviews, or planning to become a mobile app developer, this lesson will give you a strong foundation in one of the most valuable skills in modern software development. So, grab your notebook and let's dive into the existing world of cross-platform development. In this case, the application has a single code base and it supports multiple platforms. As an example, WhatsApp has one code base, but it supports Android and iOS and etc. According to this, we can run our application on multiple operating systems or platforms. Instead of developing separate versions of the application for each platform, cross-platform development aims to build a single code base that can be used across different platforms. What are the frameworks we are using for this? The first one is Flutter. Flutter is created by Google and it uses Dart. The next one is React Native. It is created by Facebook and it's based on JavaScript. The next one is Xamarin. It is created by Microsoft and it uses the C#. The next one is FireMonkey. It is created by Ambassador. It uses Delphi. Sorry, my pronunciation mistakes, right? It should be Ambassador. Cross-platform development benefits. First one, code reusability. It allows developers to write a single code base and reuse most of that code to build applications for multiple platforms such as Android and iOS. This reduces duplicate work, speeds up development, and simplifies maintenance. Why it's called code reusability? You write the business logic once. The same code is reused across different platforms. You don't need to develop two completely separate applications. But remember, we can't say 100% of the same code runs everywhere. Most cross-platform frameworks still require some platform-specific code for features like camera access, Bluetooth, notifications, or platform-specific APIs. Therefore, we should say most of the code is shared rather than all of the code. Code reusability saves our time and effort. The next one, cost effectiveness. Instead of developing separate applications for each platform, developers use a single shared code base. This reduces development effort, saves time, and lowers both development and maintenance costs. Next one, faster development. It means cross-platform frameworks often provide tools and features that accelerate the development process, allowing for quicker time to market. The next one, consistent user experience. It means cross-platforms development aims to provide a consistent user experience across different devices and platforms. Let's look at some of its limitations. Although cross-platform development offers many benefits, it is not always the best choice for every project. The first one, performance considerations. The first drawback is performance. Native applications are developed specifically for a single operating system such as Android or iOS. Because they interact directly with the device's operating system and hardware, they generally provide the best possible performance. On the other hand, cross-platform applications use a framework that acts as an intermediary between application and the operating system. As a result, some operations may experience a slight performance overhead. Although modern frameworks like Flutter and React Native have significantly improved performance, native applications can still have an advantage in resource-intensive scenarios. For example, applications such as high-end 3D games, augmented reality, virtual reality, or professional video editing software often require maximum performance. In these cases, native development is usually the preferred approach. However, for most everyday applications such as social media apps, e-commerce apps, educational platforms, and business applications, the performance difference is often minimal and may not even be noticeable to users. The second drawback is delayed access to new platform features. Companies like Google and Apple regularly release new versions of Android and iOS with additional features, APIs, and improvements. For native developers, these new features are typically available immediately because they are supported directly by the official development tools. However, cross-platform developers depend on the framework they are using. Framework maintainers first need to update the framework so that it supports the latest operating system features. Only after those updates are released can developers fully take advantage of the new functionality. For example, suppose Apple introduces a brand new camera API in the latest version of iOS. A native iOS developer can start using that API almost immediately. In contrast, developers using A cross-platform framework may need to wait until the framework adds support for the new API or until a suitable plugin becomes available. As a result, developers may experience delays in adopting the latest platform capabilities, which can affect development schedules and project timelines. Let's discuss about Dart language. So, what exactly is Dart? Dart is a general purpose, object-oriented programming language developed by Google. The term general purpose means that Dart is not limited to a single type of application. Instead, it can be used to develop different kinds of software, making it a flexible language for modern software development. One of the key strengths of Dart is that it is designed for building web applications, server-side applications, desktop applications, and mobile applications. This means developers can use the same language across multiple platforms, reducing the need to learn different programming languages for different environments. Another advantage is its easy to learn syntax. If you already have experienced with Java or JavaScript, you will notice that Dart looks very familiar. The structure of classes, functions, variables, loops, and conditional statements is quite similar, making the transition to Dart much easier for beginners and experienced developers alike. Dart is also a strongly typed programming language. This means every variable has a specific data type, such as an integer, string, or boolean. Strong typing helps the compiler detect many programming errors during development, resulting in more reliable, maintainable, and robust applications. Another important feature is Dart's support for two compilation methods: just-in-time compilation and ahead-of-time compilation. During development, Dart uses just-in-time or JIT compilation. JIT allows developers to make changes to the code and see the results almost instantly through Flutter's hot reload feature. This significantly speeds up the development process because you don't need to rebuild the entire application after every small change. When you are ready to release your application, Dart uses ahead of time or AOT compilation. AOT converts the Dart code directly into native machine code before the application is installed on the user's device. As a result, the application starts faster, performs more efficiently, and provides a smoother user experience. Dart also provides excellent support for asynchronous programming through the async and await keywords. Imagine your application needs to download data from a web server. Without asynchronous programming, the application could freeze until the download is complete. With async can await, the application can continue responding to user interactions while the data is being retrieved in the background, creating a much smoother experience. Another powerful feature of Dart is that it allows developers to write code that can run on both the client side and the server side. The client side refers to the application that users interact with, such as a mobile app or a web application running in browser. The server side handles tasks like processing requests, storing data in databases, and managing business logic. Since Dart supports both environments, developers can use a single programming language throughout the entire application stack. Perhaps the biggest reason Dart has become so popular is its integration with Flutter. Flutter uses Dart as its primary programming language to build cross-platform applications. With Flutter and Dart, developer can write one code base and deploy application to Android, iOS, Windows, macOS, Linux, and the web. This significantly reduces development time, lowers maintenance costs, and ensures a consistent user experience across multiple platforms. Dartpad is an open source tool that you play within the Dart language in any modern browser. Now type and search for Dartpad on your browser. Dartpad. Press this. Now you can see the language we use, right? Oh, we haven't any printed statement. Okay. I remove these things, right? Now you can see main function, right? Let's discuss one of the most important concepts in every Dart program, the main function. Whenever you create a Dart application, the first thing you will notice is a function called main. See? Okay. We can print anything using print statement. Inside double quotes, you can say everything. Hello, Isuri. Put the semicolon and you can run. See, it gives our output, right? So, what is the purpose of this function? The main function is the entry point of every Dart application. In simple terms, it is the first function that the Dart runtime executes when the program starts. Think of it like entering a building through the main entrance. Before you can access any room inside the building, you first go through the main entrance. Similarly, before any other part of your Dart program runs, execution begins with the main function. Let's break down this statement. The first keyword is void. It means that this function does not return any value after it finishes executing. Next comes the function name, main. The name main is special in Dart because the Dart runtime automatically looks for this function when the application starts. If a main function is not present, the program will not know where to begin execution. After the function name, you will notice the parentheses. See, these parentheses contain the function's parameters. In this example, the parentheses are empty because we are not passing any information to the function. Finally, the curly braces. It defines the body of the function. Any statements placed inside these braces will be executed when the program starts. For example, you can get this right. And I'll also use another print statement. Hello, rookie. Okay. While this program runs, both print statements execute one after another. See, first it executes Isuri, then rookie, because they are inside the main function. Besides printing output, the main function is commonly used to perform initialization tasks before the rest of the application begins. For example, inside the main function we might initialize application settings, connect to a database, configure services, load configuration files, initialize Flutter plugins, create objects needed throughout the application. In a Flutter application, you will often see something like this. Run app, my app, like this, right? This gives errors because this is an online compiler, right? Okay. Here, the main function starts the program by calling the run app function, which launches the Flutter application. So, the main function acts as the starting point where the application begins its execution, right? Let's move on to another fundamental concept in Dart: variables and data types. Before we learn different data types, it's important to understand one key characteristic of the Dart programming language. Okay. Dart is known as statically typed programming language. So, what does statically typed mean? It means that when you declare a variable with a specific data type, that variable is expected to store only values of that type. In other words, once a variable's type has been determined, it cannot later hold a value of a different type. For example, we can create int age is equal to 27. Here, the variable age is declared as an integer. Since it is an integer variable, it can only store whole numbers. This is perfectly valid, right? Age is equal to 26. This is one of the advantages of static typing. It helps identify mistakes early during development, making programs more reliable and easier to maintain. But you can't give this, right? Age is equal to 26. You can't give any string value for age because age is an integer type, right? Now, let's look at the most commonly used data types in Dart. The int data type is used to store whole numbers. You can see this example. Notice that there are no decimal points in these values. See? The next one, decimal numbers. We can use double. Okay. This is used to store decimal numbers. For an example, double 8 is equal to 5.1. Like this, right? Okay. Whenever your value contains a decimal point, you should generally use the double data type, right? The next type is string. Like Java, right? The string data types is used to store text, right? String values are always enclosed within quotation marks, right? String name is equal to, inside the quote, you can give any value. Taridu, right? And put the semicolon. See, any sequence of characters, words, or sentences should be stored as a string, right? You can give numbers, characters, anything. The next type is bool, right? Bool data type stores Boolean values, which can only be either true or false. For example, bool is logged in is equal to true, right? Boolean values are commonly used in decision making with if statements and loops. Now let's discuss dynamic, right? Unlike the previous data types, dynamic is more flexible. A variable declared as dynamic can store different types of values at different times during program execution. For example, dynamic value is equal to 100. You can print value. Like this. Then you can give value is equal to hello, and you can print it again, and again value is equal to, put the semicolon and again print value, right, and run it. See, notice that the same variable value, see, first is stored an integer, then a string, and finally a boolean value. Although dynamic provides flexibility, it should be used carefully because it reduces type safety. In most situations, it is better to use a specific data type whenever possible. Finally, let's look at var. Many beginners think that var and dynamic are the same, but they are not. The keyword var tells Dart to automatically determine the variable's data type based on the first value assigned. For example, var name is equal to the name and come out, put the semicolon. Dart automatically recognizes that Dini is a string. Therefore, this is valid. We can't use name. I change it as name1. Right? Now it is correct, right? Because we can't keep the same variable name, right? Okay. Therefore, this is valid. Again, name 1 is equal to Lahiru, right? But this is not valid. Sorry, this is valid, right? This is not valid. Name 1 is equal to 80. This is not valid one, right? See, it gives error. Even though we used var, Dart inferred that name is a string when it was first assigned. Therefore, its type cannot later change to an integer. Let's look at another example. Var age 1 is equal to 23. Dart automatically treats age as an integer. So, age is equal to 25 is correct. But age is equal to 25 will produce a type error, right? This is the biggest difference between var and dynamic. Remember, var, Dart automatically determines the type and that type remains fixed. Dynamic, the variable can hold different types of values during execution. Let's see how we can display variables together with text. In Dart, this is done using string interpolation. So, what is string interpolation? String interpolation is the process of embedding variables or expressions directly inside a string. It allows us to combine text and variable value in a simple and readable way. Instead of joining strings using the plus operator, Dart provides a cleaner approach through string interpolation. Let's look at an example. Let's get name and age, right? Yeah. Normally we can do this. Print my name is right. Now after that we can print our age. No, I am hold your age. Run it. See, my name is Tarindo. I'm 25 years old. Notice dollar symbol before the variable name. Right? The dollar tells Dart to replace the variable with its actual value when printing the string. So, dollar name becomes Tarindu 2000 hash and age becomes 25, right? This makes our code much cleaner and easier to read, right? Now, what if we want to include more than just a variable? Suppose we want to perform a calculation inside the string. For that, Dart uses this, right? $sign with curly braces like this, right? For example, let's try I clean these things. Now, int num1 is equal to 5 and int num2 is equal to 56, right? Now we want to print total of these. How? Clear it. Print sorry, total is equal to inside this dollar and parentheses you can call variables, right? Num1 plus num2, right? What is the issue? Let's see. Sorry, this should be curly braces. Right. Now you can run it. See, it gives the total of these values, right? Look at these. First evaluates the expression num1 plus num2 and then inserts the result into the string. Whenever you are using an expression, a calculation, or a method called, you should use this sign, $curly braces, instead of just $, right? Before string interpolation became popular, right? Developers often combined strings using the plus operator. How? We can do this, right? Right? And call the total. What is the issue right now? You should convert this into string value, right? To string, right? Where is it? Okay. Like this. Now you can print total. See? Okay. You can't insert integer value for this because this is a string. That's why we should convert our integer into a string, right? Okay. Although this works, it is less readable, especially when multiple variables are involved. Compare these two examples using the plus operator. I already discussed this, right? What about string values? Let's print it. String name is equal to Tarindu, right? Now you can print it simply. Plus name, right? Run it. Now you can see the name, right? We can put a comma, right? Let's say, oh, wait. Sorry, you should put the comma like this. I think so. Wait. You should include one quotation like this. Right. What is the issue? Sorry, let's try this. Name, right? Put the comma. Now it's right? Let's see. See? Okay. You can see total length via the comma, you can separate total and name. See, look at the first one, right? Then look at this, right? The second version is shorter, cleaner and easier to understand, right? That's why string interpolation is the recommended approach in Dart. Let's move on to another important concept in programming: decision making. In real life, we make decisions every day. For example, if it is raining, we take an umbrella. If we are hungry, we eat food. If the traffic is heavy, we leave home earlier. Programming works in exactly the same way. A program often needs to make decisions based on certain conditions. In Dart, we use the if and else statements to control the flow of a program. The if statement. Let's start with the simplest one, the if statement. The if statement executes a block of code only when a condition is true. Let's try it. If let's declare variables, right? Int age is equal to 18. 18 or what? Let's 50. Okay. If age is greater than less than 18, print right, run it. See, it gives this output because 15 is less than 18, right? That's why it gives this. If it is not true, it gives nothing. The condition is written inside parentheses, right? If the condition evaluates to true, the code inside the curly braces is executed. You saw, right? Okay. Then the else statement. Sometimes we want to execute another block of code when the condition is false, right? For this, we use the else statement, right? 12. If it is true, it should give this. If it is not, else is not a teenager, right? Run it. See, if it is true, he is a teenager. if it is false, because 19 is greater than 18, right? Therefore, it should print he is not a teenager, right? Instead of doing nothing, the program executes the else block. Think of it this way. If the condition is true, execute the if block. Otherwise, execute the else block, right? The next one, the else if statement. Now imagine we have more than two possible outcomes. For example, 75 and above, distinction, 50 to 74, pass, below 50, fail, right? These things about marks, right? We cannot handle this using only if and else, right? Instead, we use else if. How? Let's try marks, right? If mark is marks if marks is greater than or equal to 75, it should be print distinct, right? Like this. Then use else if marks are greater than or equal to 50, you should print pass, right? If it is not, fail, right? Okay, let's run it. Pass, right? Because marks is equal to 55. That's why it gives pass, right? When we give 25, run it. See, it gives fail, right? Because marks is not greater than or equal to 50 or 75, right? So, when we give 80, run it. See, it gives distinct because marks is greater than 75. That's why it gives distinct. Okay. Let's understand what happens behind the scenes. Suppose we have this, right? Dart checks marks is greater than or equal to 75. Yes, that's why it gives distinct, right? If it is 60, this first check this condition, and if it is not correct, it moves forward, right? Okay. Now it checks this. If this value is greater than or equal to 50, yes, it should give pass, right? Okay. If it is not true, it should give fail. That's it, right? The next topic is ternary operator. The ternary operator is simply a shorter way of writing an if-else statement. Whenever you have a simple condition that returns one of two values, instead of writing multiple lines of code using if and else, you can write the same logic in single line using the ternary operator. This is the syntax, right? Condition, question mark, expression, expression 1, and expression 2, like this, and put the semicolon, right? This is the syntax. Okay, let's understand each part of this syntax. Condition. This is the Boolean expression that Dart evaluates. It must produce either true or false, right? Expression 1. If the condition is true, Dart executes or returns this expression. Expression 2. If the condition is false, Dart executes or returns this expression. So the execution flow is very simple. First, Dart evaluates the condition. Second, if the condition is true, it executes expression 1. If the condition is false, it executes expression 2. For an example, let's check age. Suppose we want to determine whether a person is an adult. Using an if-else statement, we would write int age 20 and if age is greater than or equal to 18, you should print adult, right? Put the semicolon, and else you should print minor, right? Okay. The output is adult, right? How let's solve the same problem using the ternary operator. Int age 20, right? Now, using print, first you should give condition, right? Age is greater than or equal to 18. Question mark and first expression adult and give the second expression minor, right? I remove it, then run. It gives adult, right? The same output. You should notice how we reduced several lines of code into a single, easy to read statement. The ternary operator is best used when you have a simple decision with only two possible outcomes. For examples, pass or fail, yes or no, adult or minor, even or odd, right? If your program contains multiple conditions or complex logic, using an if else statement is usually clearer and easier to maintain. Right? The next topic is the list. In programming, there are many situations where we need to store multiple values together. For example, imagine you want to store the names of students in a classroom. One approach would be to create separate variables. Right. This works for a few students, but what if there are 100 students? Creating hundreds of variables would be inefficient and difficult to manage. This is where lists become useful. A list is an ordered collection of elements stored under a single variable name. Instead of creating multiple variables like this, we can store all the values in a single list. For example, we can do this. List, give the name students is equal to, now you can give your values, right? Tarindu, then I copy paste these things, right? Dini and image, right? Okay, put the semicolon. Okay. Here, the list contains 3 elements, right? What are the characteristics of a list? Let's look at some important characteristics of lists in Dart. First one, ordered collection. A list stores elements in a specific order, right? According to that, Dini should be the first one, right? And next one, image, right? And last one should be Tarindu, right? The order is Dini, image, and Tarindu. Dart remembers this order, right? Second one, dynamic in size. Lists can grow or shrink during runtime. For example, we can add another one, right? Like this, students dot add, add, give the name you want to insert, right? Oh, Sachinta, right? Put the semicolon. Oh, like this, right? Then let's print students, right? Print students, right? Run it. Now you can see Dini, Imesh, Tarindu and Sachinta, right? According to this, we add a new element without creating a new list, right? Similarly, we can remove elements whenever necessary. Okay. Third one, accessing elements using indexes. Each element in a list has an index number. Dart uses zero-based indexing. This means counting starts from 0, not 1, right? For example, Dini is the 0th index, first index, third and fourth, right? Sorry. Starting from 0, 0, 1, 2 and 3. We have 3 indexes, but we have 4 values, right? Now you want to access an element, right? What should you do? I need to access second one. Run it. See, Tanidu. Okay. Remember, the first element is always at index 0. This is one of the most common concepts used in programming exams and interviews. The next one, lists with specific data types. Earlier we learned that Dart is a statically typed language. Therefore, when working with lists, we can specify the type of data that the list should store. List should store, right? For example, we can give the data type like this. See? Okay. This means the list can only store strings. Adding any other data type will produce an error, right? For example, the students dot add Rehan. This is valid, right? However, the students add 100. This is invalid because 100 is an integer, not a string. Using data types with lists helps prevent accidental insertion of incorrect values and improves code reliability. Right? What are the common list operations? Adding elements. We already done, right? Also, we can update, right? An element using its index. How? students. Third value should be Sadita. Right. Now print students. See, it was replaced, right? Okay. Then we can remove in elements, right? Sorry, we can remove elements using the remove method, right? How? I wanna remove image. Students. Wait. Sorry. Dot remove image 1, right? False. Why? Oh, sorry. You should give name, right? Let's give it image, right? Run it. Oh, now you can see true. Print students and run it. See, now you can see only Dini, Tarindu and Sadita. Image was vanished. And also iterating through a list. Often we want to process every element in a list. For this, we can use a loop. How? We can use for loop, right? For string name, students name, students in students. String student in students. Curly braces. Print students, right? Put the semicolon. I clear it and run. See, what about if you give this, right? Student. Run it. Now it's okay, right? See, Dini, Tarindu, Sadita. The loop visits each element one by one and prints it, right? You can add new students, remove students, update student information, display all students. This makes lists extremely useful in real-world applications. The next question is, how can we access every element in a list without writing repetitive code? The answer is loops. A loop allows us to execute the same block of code multiple times. In Dart, one of the most commonly used loops is the for loop. There are three main variations: traditional for loop, for in loop, for each loop. traditional for loop. The traditional for loop is useful when you know how many times the loop should execute. This is the syntax. Let's understand each part. Initialization. This executes only once and usually creates the loop variable. Int I is equal 0. Condition. Before every iteration, dot checks whether the condition is true. If it is true, the loop continues. If it is false, the loop stops. Update. After each iteration, the loop variable is updated. Usually, we increase it by 1 using I++. For an example, we can give 1, right? I should be less than or equal to 10 and I++, right? Now you can print I, right? So run it. You can see 1 to 10 numbers, right? Start from 1. It should be end with 10, right? If you remove this, it should print 1 to 9, right? See? Okay. The next one, for in loop. Suppose we have a list of student names. Instead of using indexes, Dart allows us to directly access each element. How? First, you should create a list like this. How? List string students is equal to, now you can give names, right? Isuri, Rookie, Lahiru, right? This is our list, okay? Now you should give this string student in students, right? And print student, right? Okay. Run it. See, it gives Isuri, Rookie and Lahiru, right? This syntax is cleaner whenever we simply want to read every element. Sorry, we simply want to, right? Another way to iterate through a collection is using for each method. It's different, right? Erase this. And now students dot for each, right? Where is it? For each. We can't find, right? So for each, right? Yeah. Then parentheses, inside parentheses you should give student, right? Then open curly braces and print student, right? Come outside, put the semicolon. Let's see. Sorry, you should remove this. And you should close it like this. I think so. See, now it's right. Okay, run it. Okay. This produces exactly the same output. We later learned that the code inside for each is written using a function. The next one, arrow function. Sometimes a function contains only one statement. Instead of writing curly braces and the return keyword, Dart provides a shorter syntax called the arrow function, also known as the fat arrow function. For example, int square, int number, return number, right? The same function can be written as this, right? Int square, int number, using arrow function, number, like this, right? I commented, right? Okay, now it's okay, right? You can use this version. You can use this version instead of this, right? The arrow means return the result of this expression. Arrow functions make the code shorter and easier to read. They are commonly used with lists for each function and Flutter widgets. So far, we've stored multiple values using lists. However, lists store values using indexes. Sometimes we want to store data as key value pairs. For example, a student has name, age, GPA. Instead of remembering index positions, we can use meaningful keys, right? How? Using this, right? Map string, comma, dynamic, close, and students, open curly braces. Now, name is Suri, right? Comma, age, and next one, GPA, .4, right? You should use comma, right? Put the semicolon like this, right? Okay. Sorry, we should assign, right? Sorry. Now it's correct, right? Here, name is the key, Isuri is the value. To access value, print like this, right? Print students name, right? Put the semicolon and run it. See, to find the number of key value pairs, we can use this print students dot length, right? Now run it. See, we have 3 key value pairs, right? Maps are widely used because they represent real-world data naturally. The next one is class. Object-oriented programming is based on 2 concepts, class and object. A class is simply a blueprint. Think about building a house. Before construction begins, an architect prepares a blueprint. The blueprint describes what the house should look like. Similarly, a class describes what an object should contain. I create class named student. Class student, curly braces. Now you can create variables, right? String name is equal to rookie, right? And int age is equal to 25. This class defines what every student object should have. Now we can create objects, right? It's like Java, right? How? Student, give the object name S is equal to student method, and now you can print name, right? Print s dot name and s dot age, right? Now okay, delete this, right? Run it. You can say rookie, right? We can print age like this, age, right? 25. A class is the blueprint. An object is the actual thing created from that blueprint. The next one, nullable and non-nullable type. Beginning with Dart 2.12, Dart introduced null safety. By default, every variable must contain a value. Example, string name rookie, right? This variable cannot store null. The following code is invalid, right? We can't do this. Name is equal to null, right? See, it gives error, right? I remove it. If we want a variable to hold null, we add a question mark. How? String name. Like this, right? Now, name is equal to null. Name is equal to null, correct? Is perfectly valid, right? Wait, I remove this and remove this, right? Okay. String null name, right? Name is equal to null. Okay. Now this is the valid. This is valid, right? The question mark tells Dart that this variable is allowed to be null, right? What is null safety? Null safety is a feature that helps prevent one of the most common programming errors, using a null value where a real value is expected. Instead of discovering the error while the program is running, the Dart compiler detects many of these mistakes during compilation. This makes applications more reliable and reduces unexpected crashes. The next topic is null-aware operators. Dart provides several operators for safely working with nullable values. Safely working with nullable values, right? First one, null coalescing operator, right? It looks like this, right? This, right? Double question mark. String, let's try. Right. String name is equal to username, right? We use this like this, right? Name one, right? Now it's correct, right? Now you can print name one. Run it. Now you can see guest, right? If username is null, Dart uses guest. The next one, null aware access operator. Normally, person dot name will cause an error if person is null. Instead, person this checks whether person is null first. If it is null, Dart simply returns null instead of throwing an exception. Third one, null aware assignment. The next one, null aware assignment. We can represent it like this. Suppose we only want to assign a value if the variable is currently null. String city Colombo. Now you can print city Run it. See, you can see Colombo. If city already had a value, Dart would leave it unchanged. That brings us to the end of today's lesson. Today we covered the fundamental concepts of Dart, including variables, data types, string interpolation, decision-making statements, loops, lists, maps, classes, functions, and null safety. These are the building blocks that you'll use in almost every Dart and Flutter application. I encourage you to practice each concept by writing your own programs. The more you practice, the more confident you will become. If you found this lesson helpful, don't forget to like this video, share it with your friends, and subscribe to the channel so you won't miss our upcoming lessons on Flutter and cross-platform application development. Thank you for watching, and I'll see you in the next lesson. Happy coding!